Okay, so I've rewired the circuit in a slightly different way on the breadboard. I've got a nice little heatsink on there, which is just slightly warm at the moment. What I've done, I swapped the collector and emitter over on the transistor, so it's in a higher amplification mode here. I was always a little bit confused why Fantex did it that way around, because I'd always simulated it this way around because it get a higher gain. At the moment I've got a lot of fans attached. I've got 2, 3, 4, 5, 6, 7, 8 fans attached to the circuit. Altogether, altogether I've got the wire stuck in there. Altogether 2, 4, 5, 5, 5, 0.62, 0.7, 0.8, about 1.1 amps attached to the circuit, and at the moment it's running at about 4.9 volts at the lowest duty cycle. So I'm just going to crank it up. Now I don't get full 12 volts. This is one of the things I've noticed. The more fans I add, the more current I add to the circuit, the larger the voltage drop. So I'm dropping about 1.1, 1.2 volts there off my 12 volt rail. I'm reading 0.9 amps, so that's obviously because I'm dropping a volt. I'm dropping a number of amps there as well, a number of milliamps per fan have been dropped off. But I reckon that's still pretty good speed considering how many fans I've got attached. The transistor itself is only just heating. It's quite a large heatsink, this one, and it's screwed in to the transistor. So what I'm going to do now, I'm going to swap it back to the other configuration and just pop it in there like that, and I'm going to see what happens. Now do bear in mind this was running at almost 11 volts before. Now I've got 7.5. So it's given me an extra 3.5 volts of energy, of potential difference there, and it goes right down to, well, basically stopping 3 volts and so on. So there's a fair difference. I think the fans are beginning to stall. Now turn that down, it's a bit noisy. Now this still isn't quite maxed out. I've still got a little bit left on the trimmer. So if I increase that, you can see the voltage is still going up. So even though I've got over an amp of fans on here, I've still got a bit of adjustment that I can do. So there it is, there's the end, so it's 7.5 volts. So still got a bit of room there. But obviously I will have to sacrifice some of that top end speed. So I dial it down to where it should be. 1, 2, 3, 4, 5, quite difficult to do, 6, 7 turns, roughly 7 turns until it gets down to the right point for these fans. Just thought I'd share that. That's heatsink. Heatsink is hardly really warm. If I took a heatsink off, it'll be scorching, absolutely scorching. But at the moment, because it's quite a big heatsink, that can take a fair bit of heat. So I thought that was interesting. So I've taken off some of the additional fans. I've just got 4 fans attached now, about 0.55 of an amp, just to show the difference. Get a little bit over 11 volts. Down to 5. Again, I've set the trimmer up for that. Obviously it's a lot easier for the circuit to do this, and the heatsink will now not get very warm at all. This is probably 10 times better than my little picture hooks that I was using. Apart from that, the circuit is essentially the same. I've got a couple of 470 ohm resistors here in series with the trimmer, so that I don't blow the trimmer by putting too much current through it. Got the fans attached via the breakout board there. Everything's the same. So I'll just swap this again. I'll get this at 5. Just put some stray capacitance into it at the moment to swift it resettle. It's 4.8. It's just creeping up. Let's call it 4.85. I'll just swap this into the other part of the circuit. There we go. And these are struggling to push 3 volts. But if I crank it up, so we went up to 7 volts. And what I could do is increase the power going through here, compensate. So it's coming up. It should top out soon. There you go. I'm just adjusting it, nothing's happening there, it's just wasting energy. So 10.95. I was a little bit down on, and there you go, it's not going down very low now because it's a 10.95, so I would actually have to reduce that. So here we are showing 5 volts. And it goes up to 11.2. So I can replicate that on the other part. So it's dropped a couple of volts there. So now we increase the power. It might just turn itself off. So if I pop it back down to minimum, then increase the pot towards 5. Takes a little while to get there. Stop, missed. I'll just put it back on. There you go. Whoop, not a bit too far. There you go, 5 volts. Now if I increase the speed, it's very similar. So all it's allowing me to do is basically run additional fans if I want to, because the results are pretty much the same between the two. All it's allowing me to do is burn up less energy in this part of the circuit through these resistors, and effectively allows me to have slightly more resistance in this part for the same output. So I think it's probably a awesome advantage to me. I've just done some calculations, and on the revised wiring as here, I seem to be getting 0.2 volts extra on the circuit at full speed. Obviously as I decrease the amount of load on the circuit, I will see more gain towards 12 volt and beyond with this configuration. So I might give this some more tests, perhaps modify one of my boards here, wire it up properly and see what we're looking at. 'Cause I've got a version 2 kicking about somewhere. Yes, here we are. So I've got this version 2 here. Well, it should be quite easy to modify the wiring for that, so that's the other way around. I can give that a go. One addition, one thing that is swapping of the circuit wiring has highlighted to me is that the 5k potentiometer that I've got fitted is totally inadequate for anything less than about 0.3 amps, 0.4 amps. So even though it's better for high load, it's not so good for low load. I would need something like a 10 or maybe a 20k potentiometer on there to cope with low load. And here's another illustration of the difference in power of these circuits. So I've got the two fans on, that's 0.35 amps. No, 0.25 amps, as you can see there. 11.7, still a little bit of a sag there, but not too bad. This basically, I can't reduce the power on this any more than it is. This is right at the bottom of the pot. But if I put it on the other side of the circuit, and there you can see it's gone down to 8.5, almost 9 volts. So there's a big difference there, big difference between the two. Just a quick explanation of how the circuit works as regards gain. So you've got a little transistor here which takes the PWM signal. The signal from that basically goes up to the PNP and is inverted, but to modify the amount of power going through the circuit, it passes through these resistors here and this variable resistor here. So if I increase the resistance of this series, a little bit less power gets into the transistor. So the more power I have come through here, the more energy is dumped in the transistor, but also the more energy it reaches the transistor and is pushed through into the fans. Now we're talking small amount of current here, we're talking maybe 20 milliamps coming through this bit of the circuit, but this one will maybe have 700 milliamps, so it amplifies the current quite a bit. The standard probably around 40 or 50 times current gain. So if we put 10 in there, we'd get 500 out, 20 in there, 1000. It's never as simple as that, because as these put more energy out, put more current out, they actually have less gain. So you may have 100 at say 10 milliamps, but by the time you get to sort of 50 milliamps, you may only have a gain of 30 or something. It's not linear. Nothing in analog is linear. So I just thought I'd show you that. Yeah, that's all good. All working nicely, even in the and I suppose thinking about it, I could even have a board wired up in both ways, and at the flick of a switch we could have a turbo boost option, if we wanted such a thing, where you'd have the same resistors in there, but a switch similar to the switch I did for version 1, where if you're running low power fans, say 0.1 up to 0.3 or 0.4, you'd have it in low setting, and yeah, this is and then for high power setting you could just flick a switch, the wires would be inverted and changed around, and all of a sudden you'd have a higher power setting, which it's okay. You could use the same resistors, but it obviously would add some complexity to the circuit because I'd have to switch 2 wires over.